This example I think we may have done before. It is converting the degrees Celsius Fahrenheit into degrees Celsius. So we're going to make our degrees Celsius our dependent variable and the degrees Fahrenheit our independent variable. And I've just kind of sketched a graph here with some approximate scales so I can draw this graph in. So for 212 degrees, we're going to be at 100 degrees Celsius, so right about here. At 37 degrees, or sorry, 98.6 degrees, we're going to be about 37 degrees Celsius. That's about here. Okay, and then we're going to, there's our graph. So to find the equation of this relationship, we want to first of all find the slope. So I need my slope triangle. In my slope triangle, my change in y is going to be 100 to 37. So the change in degrees Celsius works out to be positive 63 degrees change. Okay, the change in the degrees Fahrenheit, okay, we're going to do 212 minus 98.6. Okay, and that gives us the change in degrees Fahrenheit is equal to 113.4 degrees. Okay. So my slope then, my slope ratio is going to be my change in y over the change in x. And I get 0.5 repeating, so that is as a fraction 5 over 9. So it's 5 degrees Celsius for every 9 degrees Fahrenheit. Okay, so that's my y over my x. So once I've established my slope, I want to find out my y-intercept for my graphing form. So I'm going to do y equals mx plus b. My slope is going to be 5 over 9. The b is unknown. I'm going to plug in an x and y pair. Okay, in this case, I'm going to use my whole number pair here for my x and y, and then that allows me to solve for b. I just have to be careful. My independent, or my x, is going to be my degrees Fahrenheit. So I'm going to end up with 212 degrees Fahrenheit gets converted to 100 degrees Celsius. Okay, so then multiplying that out, I get 100 equals 117.7 repeating plus b. Okay, so then b works out to be 17.7 repeating. Okay, and since b is degrees Celsius, okay, that's going to be, so it's going to be negative because I'm going to subtract from both sides. So it's going to be negative. So my degrees Celsius is equal to my slope times degrees Fahrenheit plus my y-intercept. Okay, so slope is 5 degrees Celsius for every 9 degrees Fahrenheit. My y-intercept is always in the same units as my y value. It's going to be negative 17, and I'm going to round that to 0.8 degrees Celsius. And so what does that mean? The y-intercept represents the value of, or let's say that degrees Celsius when it is 0 degrees Fahrenheit. Okay, so that's what that negative 17.8 represents. Add 0 degrees along the x, it's going to be negative 17.7 repeating along the y. Here we have a charge of electricity. Electricity is determined by the number of kilowatt hours plus a service charge. And we've been given the relationship of cost to kilowatt hours, so that kilowatt hours is my independent variable and the cost will be my dependent, because the cost depends on how much I use. So along the y is going to be my cost, and along the x is going to be my kilowatt hours. And so we're going to maybe go up to 400 kilowatt hours here, and let's say our charge is $30 up here. So add about 150 kilowatt hours. our charge is about 18, should be a little bit past halfway there, so $18.75. And at 360, so what was this? This is 150, 360, maybe somewhere around here, is going to be close to $30. Okay, so I just want to get a visual idea what my relationship looks like. I know I have positive slope. So my change in Y is going to work out to be 29.25 minus 18.75. So I get $10.50, an increase of $10.50. That happened over a charge of, not a charge, but the kilowatt hours, the change in kilowatt hours works out to be positive 210 kilowatt hours. So we went from 150 to 360. Maybe I'll just write that in a little bit neater. So that line is 360 kilowatt hours. So then my slope works out to be $10.50 for every 210 kilowatt hours. As a unit rate, 10.5 divided by 210 gives us $0.05 for 1 kilowatt hour. Okay, so there's my slope. I want to solve for the y-intercept. Okay, the y-intercept is the initial charge, the charge when we don't use any electricity. So my charge is equal to 5 cents per hour times the number of kilowatt hours plus the y-intercept, which we'll call B. Okay, so using an XY pair, let's use 150, 1875, and we're going to plug that into our equation and then solve for the only unknown left, which is going to be the B value. So we have 150 kilowatt hours times 5 cents an hour plus B. So we end up with 18.75 equals $7.50 plus B. So that the y-intercept works out to be $11.25 is my initial charge. Okay, so there's my y-intercept. Okay, that's going to be $11.25. So now I can write my equation, and maybe we'll write this one in function notation. The charge in terms of the kilowatt hours is going to be 5 cents per hour times the number of kilowatt hours plus my initial charge of $11.25. Okay, so there's my equation for that. Now I can use this equation to then calculate the charge for 400 kilowatt hours. So I'm going to put 400 into my equation. Okay, and then in doing that, I can then calculate my kilowatt hours. Sorry, my charge is going to end up being $31.25 for 400 kilowatt hours. And so that is an ordered pair. So 400 kilowatt hours and $31.25 is an ordered pair in that relationship.